do social events until you kill somebody.
Yeah, no socializing at all.
You can kill in front of other people.
Yeah.
No, you can unless they're not in the game. If they're not in the game, you can.
Yeah, but like what if we're at like an event that's
Then you go, everyone looks that way, and you're like, get
But then he'll be like, no, I'm not going to look the other way. I'll be like, no, I'm going to look the other way.
Yeah. No one will look the other way.
Okay, well, I don't count. I can see it.
Oh yeah, you can.
Not on purpose, I was just...
Wait.
All right. Are you gonna whip that out and poke it
Yeah,
out?
that's exactly what I said. I was like, no, that's not going to happen.
I'm going to be able to whip this out just as fast as Kiss going to be able to whip this out of his pants.
All right. Here we go.
I think you got approved by Mr. Nelson. I disagree.
He got
Stop.
it approved.
Stop. Okay. So, find general solutions to differential equations, and sometimes we call them DEs or DEQs for differential equations. And that's really what they are. They're equations that have derivatives in them. So this has a derivative in it. It says the derivative is equal to 6x plus 5. Well, guess what? That's a really easy one to solve if you've passed your gateway tests.
Or if you haven't, you can still know what it is.
Yeah, and if you haven't, you're going to get a detention next Wednesday.
Next Wednesday.
So if you need to pass, it by next Wednesday. Yeah. So you need to pass by next Wednesday, or else you're in detention. So what do we have? And that plus C makes it the general solution, okay, which is different from the specific solution. All right, so the general solution would be plus C. I mean, don't you sort of like that?
Yeah.
Like, I mean, if that's what the homework's going to be like. All right. Here we have another differential equation. This time we're writing it as f prime. All right, so what do we have?
4x squared plus ln x plus c.
Absolute value of x plus c. All right. And we have a last differential equation, 2x plus cosine of x.
Squared,
Plus sine x.
plus c.
You just solved 3 differential equations. Yeah. Do you have a question on those?
That was
Let's do it
really
again.
easy.
Yeah, you'll like that. Now, we're going to get to the point where you might have something like that. And that all of a sudden is not as easy, right?
Subtract y and divide by x.
Well, so no. So here's what, if we do, what's the problem?
Yeah, well,
We don't know why to begin
there are
with.
2 variables.
Yeah, so we have y in our answer. So we're going to have to contend with, like, is there a way of solving this so that we can get an answer or not? So I'm merely foreshadowing the fact that they might not all stay this easy, but that's okay. We're going to learn strategies to figure some out. So let's go back and do some more that are easy, because that was fun, right? Yeah, it was. We like that. All right, so this one says find the unique solution. Sometimes we'd say find the specific solution, and to the initial value problem, IVP. Initial value problem is really just another way of saying a differential equation that gives you a specific condition. So we're giving you an initial condition. What can you solve for us? So, all right. So we have the derivative is equal to 6x plus 5. Asa, give me the function.
The function, that would be 3x squared plus 5x.
Don't stop there.
Oh yeah, minus 3.
All right. Before you say minus 3, what would you have said?
Well, I would have said plus c.
Okay.
But then you could just plug in y of 0. And then
Okay.
you would get 3 times the square plus 5 times 0 plus c. So then basically you find out that y is
All right, so Gabby and Ace are saying C is equal to -3 according to this initial value.
Yes.
All right, so that's a specific solution, or sometimes we call it a particular solution, as opposed to a general solution. The general solution is going to be the plus C. All right, Derek.
So the antiderivative of 3x is 3 times x squared plus 2.
And we know the initial condition's 37. Can you do that in your head? Yeah, I think so. All right. One more. All right, Kaylee. The derivative is equal to sine x.
Negative cosine.
All right. Now, whenever we have a trig function or like an exponential function, you actually have to think about what that initial condition is going to mean. So we want to solve for C, and we have 0, 0. So you want to keep going?
Cosine of x is 1, so C is 1.
All right, so the cosine of that's going to be 1, but it's going to be -1 plus C, so C is equal to 1. So the particular solution is negative cosine x plus 1. Are you all right with that, Gabby?
Yeah.
So there's an example where, like, you can't just plug in what value they gave you for C. So it works well with polynomials, but with trig functions and exponential functions in particular, it does not work well. You want to ask a question? You like this, don't you?
Yeah.
Come on, say yes. That was weak.
This is what we did last year.
What do you mean?
Last semester?
Last chapter.
Oh, yeah, sorry. Yeah, so it sort of does take derivatives and antiderivatives and bring them together, and it feels a lot like what we've done already, right? And that's another reason why a lot of students like it. It actually feels like a review. And again, we're going to learn some new strategies, but it feels like a review. So let's take a look at 7. Now, oops. A pretty interesting differential equation. This differential equation says xy prime is equal to 3y. And if I asked you to solve this equation, you don't really have ways of solving it right now. But if I give you the answer, we can check to see if it's right. So what if I told you, hey, guess what? You know what the solution to this is? The solution is y equals x cubed.
Okay.
Plug in x
What's
cubed.
all that music?
Find the derivative of that, and then we can plug that in for y prime.
All right,
So
so the derivative is...
Y prime will equal 1/4, or
3 times x cubed over x.
3x.
yeah.
So you know what I did notice? When people were doing arc length on the test and it asked for the derivative, some people did the antiderivative. So...
Probably do that.
Also, no, it
Great.
didn't take long.
I just have something else to stress over now.
Okay. Oh, sorry. No, not... All right, sorry.
So now if we
Well,
plug
so-
in
that has this
X
marking there.
So
times 3x squared.
we're going to... Let's plug in, and whenever we see y prime, we're going to plug in 3x squared. So it's going to be x times 3x squared equals 3 times, and wherever we see y, whoops, we'll plug in x cubed. And really what we're asking ourselves is this true? And you get 3x cubed equals 3x cubed, and that gets a check mark and a smiley face, and we just proved that it's true. We just proved that this is a solution.
Oh, never mind. No.
Go ahead. It was actually like a 2-step proof. It sort of went by pretty fast. But do you want to ask questions on it?
Oh, wait.
Would you ever ask us a question
yeah.
saying, like, show that this equation is not a solution of the other equation?
I suppose you could. It wouldn't be as interesting, because there are probably an infinite number of wrong solutions.
Yeah.
So Yeah, sure. So you showed me that one isn't a solution. It's more interesting to say, can you show me which one is a solution? As a matter of fact, to be honest, Gabby, we're going to get to the point where I'm not going to ask you to show me that it's a solution. I'm going to be able to give you this problem, and you're going to be able to tell me, oh, you know what? This equation is the same, has the solution of y equals x cubed. And you're not even going to... No, you don't. You don't have the strategy. You just need to learn the strategy. And we'll get there. As a matter of fact, let's see. Could you tell me what the solution to that is?
1, 0, e to the x.
Say it loud and proud, Will.
E to the x.
Yeah. E to the x is the solution to y prime equals y. Isn't the derivative of e to the x equal e to the x? Right? So that's the solution to that. Now, Gesundheit. Now again, Gesundheit. Will didn't have a strategy or anything. He just, you saw it, right? You're thinking, oh, what function has itself as its derivative? Hold on, let me think if I can come up with one more. What about... No. All right. This is, we're not going to do this, but I'll just show it to you anyhow. That's called a second order differential equation. And it's a second order differential equation because it includes the second derivative. So can you think through this? And, wait, is that true? Nope. Shoot, never mind.
Is that negative y to the 11th?
No, it doesn't work though. Oh yeah, it does. Yeah, okay, it works. Okay. A solution to this would be y equals sine x.
Because then the derivative of sine of x is cosine x, and the derivative of negative cosine x is
Negative sine x, right? And the negative of the negative would be positive. Yeah. All right. I was a little anxious about that. I didn't think it was going to work. Okay. And what do we have? A word problem to finish up? Let's see. All right, so this actually looks a lot like last chapter, as Betsy would say. Where do you want to start? All right, do we know what the acceleration is? -8. So all right, so I'm going to put plus c. So the antiderivative of -8 is -8t plus c, but Zach says, you know what? It's polynomial, so I know the initial velocity is 14. So I have velocity. All right, now, here's a key step. Find the distance the object travels during the first 3 seconds. You have two choices, two correct choices. You have one wrong choice. I'll take a correct one. Go ahead, Zach. All right, so if you want to find the distance the object travels, you can take the integral of velocity. And since it says distance, I actually think we would need to take the integral of the absolute value. Because I think it crosses, I think it goes from forward to backward somewhere around 2 seconds, a little bit less. So that's one thing you could do. Another thing you could do?
Oh, I know. Well, I think it's wrong. But then I hope it's not right. So it's but
Okay.
if you find position and then plug in 3.
You could do that.
That's right.
So if you wanted to, you could find the position, which would be -4t squared plus 14t. It is plus c, but I'm going to call the initial position 0. So I'm just going to say 0, 0. You could then plug in 0 and plug in 3. Now,
No, that's not what I mean. I mean, just plug in. Oh, I guess it is the same.
so it is, except for here. All right, so you're a little bit wrong, which is good, right? You want it to be a little bit wrong. So if you plug 3 in, that's just going to tell you how far from the starting point you ended up. The problem is this velocity goes from positive to negative, so we'd actually we need to break this up and find how much position we traveled from 0 to 14/8 of a second, and then from 14/8 seconds to 3 seconds. But that would be fine. Like, that strategy in general is good. Anyone want to go the wrong way now?
Plug in 3.
No, that's sort of does, like for position. Yeah, plugging 3 into velocity would be wrong, but plugging 3 into position sort of works if it asked for displacement. All right, so this is what some of you did. To find the position, some of you actually integrated the position function. And the integral of position is like, doesn't have a physical value to it.
I remember didn't you say that the day before the test?
I did. Like I said it.
Units on the test.
I said it many, many times throughout the chapter that many students tend to integrate position to find position, and it's the integral of velocity. Okay. So this is bad. And if you wanted to do this, I would probably take a look at, well, we could actually probably figure that out. But then I'd need my calculator anyhow. All right. So what is it? Negative 8t plus 4. Negative 8. Is that the displacement or the total distance? Okay. So Zach says if we were due to the absolute value, we'd get 18.5, and that includes distances forward and backward, because the total distance is going to be positive and negative. And if we were to take a look at that picture, negative 8t plus 14, is that what it was? Yeah, it is. Okay. And I'll go from 0 to 3 seconds, and I don't know, maybe negative 10 to 15. I'm going to. So first I want to just show you that the velocity, we have this positive area up here. That's the velocity going forward. And then we have a negative area down here, which represents the distance, the velocity going backward, or a negative distance. So this is like up here steps forward, and down here steps backward. And Gabby said, hey, if you really want to use your calculator to do this, you'd insert math, number, absolute value, and now it would make all of your steps positive steps. It would take your backward steps and make them gesundheit forward. And here's another important thing. What was that? That was 14/8, 7/4, 1.75. It's important that when if you want to say that you're doing this, you should say, hey, I'm going from 0 to 1.75 of the velocity function plus 1.75 to 3 of the velocity function. Or you could say, I'm just going from 0 to 3 of the absolute value of the velocity function. Sorry. Since I should say this. Since this is negative, I should say plus negative, because I need to take the opposite of that because it's below the x-axis. Yeah, or you could do the absolute value. That's fine too. Or you could say, hey, I graphed the absolute value, and then I did calc 7, which you can't just say calc 7. Like, that's not an answer. You can say, I did calc 7 to evaluate this calculus setup and got 18.5. But you have to remember, like, the calculus setup's the important thing. It's what sets you apart from someone who just knows how to push buttons on their calculator. You know more than that. You're better than that. You're the top 10 smartest percent. All right. You want to ask it?
If it looks like that, if we did that like that, would that be right? Do you know what I mean?
If you,
we have the equation for the integral, and then we write calc 7. Is that okay?
yeah. So if you write,
Write out a 7.
if you write, look, I did that. If you write this and you write, I did calc 7 to evaluate and got 18.5. That's fine. But you can't just write as an answer calc 7, 18.5. Right, because it doesn't mean anything. The important thing is the balance between, like, conveying your calculus knowledge and using technology like your graphing calculator to make some of the like manipulation easy, the arithmetic easier. Okay, and I'm never against making the arithmetic easier. I can totally get that. But with that said, you have to make sure like you're showing your calculus knowledge. All right, do you want to ask any questions about differential equations? So far, you like them? Mm-hmm. Yeah. I thought you would.